Have you realized?
Yeah.
Yes.
But that's a big box. What else is in there besides the SBC? What are all those weird doodads? Is it
It's like a keyboard and the screen and everything. And it's got, it's hard to tell from the picture here, but it has a little like thermal printer thing that can take that stuff.
Is it a mechanical keyboard?
It's it's like a little rubber. I haven't actually felt the.
Do you attach each key by yourself? Is that part of the kit?
Yeah. So here's the important guts, and so it's got this little keyboard thing that's just. I guess the keyboard's largely assembled.
Okay.
Although these connectors look like the same pogo thing you were just talking about. That's kind of funny.
All right, let's hold off on the deeper dive until we hit record, I guess. And then we can start by examining that kit.
Yes. Do that.
Oh, it's already recording?
Yes, I guess. I don't know. I studied the stream.
It's live.
Yeah. So, yeah, I can talk about the build I've been doing. So let me pull up the Amazon thing I bought.
And so, Rhett and Venkat, you have the same kits, or these are different versions of the same kits?
I think they're the same, right?
The rover, the Galaxy 4, yeah, that's the same. Yeah, I just bought it on sale on Amazon Prime Day. Yeah, mine is over here. I think mechanically it's at the same state as Rhett's. I also just have to add the solar power, but I haven't yet actually turned it on and like I tried to run it. So I'm assuming there's like the video you showed, Rhett, is it looked like just some basic script that's obstacle detection and back off or something.
Yeah, so we were following the kind of lesson plan version of the assembly. So it's not just fully assembling it and then using their final piece of software. And so in the lesson system, you kind of like build up both skills and complexity in the project. So the very first interesting one, according to my daughter, was when we can actually make the motors turn, and then you can disconnect it, you plug the battery in, and then it can just like run. And then when you finally wire up some sensors, then you can get some sort of obstacle avoidance thing. And it has both IR based sensors that you can put kind of on the side, and then it can detect if there's an object on the left or on the right. And then so we played with that for a little bit, and that does not work outside at all. Like we couldn't, with the UV light was just like not gonna work.
Yeah, these two are the IR sensors, and then it's got the standard ultrasonic sensor.
Okay.
Yeah, and so in the class, it sort of runs you through how the sensor vaguely works in kid sort of terms, and it's actually a little bit annoying how they try to describe it, because they're like, it's like your rover has like they mix metaphors all the time. So it's like this sensor is like if your rover was a superhero and it has superpowers, and then it tries to use like superpowers as the metaphor throughout the lesson. It's just,
oh God,
okay.
I can see that would be annoying even to a 9-year-old.
Yeah. Yeah, I was like, just get on with it already. She doesn't really want to read quite that many words. Just like, let's how do we do this together? But so the code that you're using to just like basically run through you always get like a very first sample is literally just how do you read the sensor and print the output to serial. And then you start to integrate that into a more kind of sophisticated package of saying, it can read the sensors, and then you can make the motors change based on what you've read.
And the code is in some GitHub repo or something, or
the code is in a GitHub repo. In the lesson version, it's also like in line, and so she pulled it up in a browser. And I taught her how to use copy and paste, which kind of blew her mind because she was starting to like type these things out. She was just like, wow, this is really tedious to type C code and make sure you get all the semicolons right. And I was like, let me show you a trick. My daughter, who only knows how to use an iPod or iPad.
That's pretty cool.
On the computer, she's trying with her finger to move the things.
Yeah, sometimes. Well, what we discovered is because she was using the lesson on her iPad, so we had multiple screens, and then she had the laptop with Arduino running, and then it turns out if you put them together and the same account is on both, they just automatically act as a second screen, and you can take a cursor from the laptop over to the iPad and just like start like scrolling with the mouse.
Really?
And we set up like it just was an accident that this happened. It was very confusing, but she loved it. She was like, "Oh wow, I can use a mouse on my iPad." Oh, okay,
Cool. Yeah.
but so the kit, you were going to bring up the Amazon listing for it or something?
No, not the kit. I just wanted to show the hard drive setup for the ARPA that I just bought.
Oh, okay, yes.
Kind of cool because it was more complex than I expected. Let me pull up a couple of tabs and have them ready. So let's see, what else do I have? Okay.
Well, while we're talking about the rover thing, let's I wanted to show something. The board that I pulled up.
You got the details from the guy you emailed?
I didn't get the details, but you can kind of learn a lot by what just by what you can see on the board.
Okay.
I just have to find this tab that I lost. Typical.
I know the feeling.
I've only got 30 of them. What is this Sunfounder that was called?
Yeah, Sunfounder Galaxy.
Galaxy RVR. Yeah.
All right, let me bring this up here. Let me share. So this is the GitHub repo for the project itself, which does have, it has both the lesson, like all the code that comes for the lesson, all the lessons in here. And then it's got, I think, one final, like, this is the complete package that you're going to use all the functionality of the rover. But I thought that it had the full thing in here. Where's the project page for this?
Oh, the breakout board picture. Okay.
There we go. So that's a close-up of all the components here. And then, yeah, neither of us have gotten the camera thing and the solar to work.
Yeah. Oh, they have a weird strip of colorful LED lights on the underside of the chassis.
Yeah, there's LEDs.
But that's why there's a purple crap under there, I'm guessing.
Yeah, and then so here's the lesson thing that we were going through. Oh, here we go. Here's the shield. So you can't really tell anything on here, but this is plugging into just an Arduino Uno, and so those are the pins that are available, and yet it's running six motors. It's got the LED breakouts. It's got IR sensor left and right. It's got this camera thing that's going to a camera like breakout board, and then this is the ultrasonic. And then you can plug in and charge off of the solar or off of USB-C, and then the battery plugs in here. I looked up the components that I could see just based on the like model numbers written on top, and this like U7 and U2 are like the bridges, the H bridges for the motor controller. And so there's one for the left and one for the right, and then they're all just like wired together. And then everything else, all these other ICs are really just about power management and the charging circuit.
When you say wired together, do you mean daisy chained or like parallel, or how are the sharing amperage? Because that edge bridge looks like it can handle 2 motors, and there's 3 on each side, right?
I think those are actually single. They're 2 H bridges, so they can really handle 1 motor, and they're pretty small, which makes me think they can't put out very much. Unfortunately, the data sheet for that particular chip. Let's see if I can pull that up.
It looks like it has 4 in and 4 out. So I'm guessing those H bridges are for 2 motors each. So maybe if they're wired together, they produce like enough amperage to drive 3. So you basically get like 2/3 power.
Yeah, or they just run hot and they're probably going to fail eventually, but yeah, I don't know. But so here's the chips that I pulled out. So the motor controller is this TC618, and I could not find a data sheet that was in English. Like this is the only thing I could find. Which it has a schematic, and it has some numbers, but it's tough to interpret.
The schematic looks simple enough that we can probably interpret it, though. Yeah. Those symbols, we can look up the symbols and see. Oh, but there's like the 2 big blocks with Chinese lettering, so I don't know what those.
Yeah, the thing that I really want, and here's like the pinout.
Oh, ChatGPT. This is a classic case for ChatGPT translated. But yeah, we can probably figure it out. It's probably a Texas Instruments original that they copied or something like that. This looks like a very...
It's confusing that like there's no like obvious similar part that's been...
Yeah. Okay. Good.
What?
Yeah. In general, this build, I can see why it's so cheap. They've like done a lot on a very small budget, and you can see where they've cut corners. Like all the joints are just lock nut screws. So a screw with a lock nut that you tighten and then loosen a little bit.
Yeah.
It's not a very robust way to create a joint. So I wouldn't stress it too much. But yeah, I'm very impressed with how much they've pulled off. There's a lot in the package.
Yeah, and I think that the wire routing certainly leaves a little bit to desired. I spent a little bit of time some wires out of the way so they didn't rub up against the tires. They're just not quite designed perfect for it. But I will say, and you haven't run yours yet, but like this I haven't really seen a rocker bogie system in full force, but this baby can climb. Like it tries to climb up walls and up my bike, and like it will take the rover vertical if you don't stop it. Like, and it wants to go. Like 6-wheel drive with a rocker bogie system is like, holy crap! And I've seen it crawl over things that are like more than its own wheel height by quite a bit, and it's wild.
Once we both get ours up and running, one interesting VPN type experiment we could do is have one of the rovers mirror the other over the VPN, like literally copy its motion. It might be interesting to try.
So I spent about an hour before this call trying to figure out like what would the next compute step be if I don't want to have an Arduino Uno as a piece. Like I kind of want to plug a Raspberry Pi into it somehow. Yeah. And figuring out the motor controller bit for that is so like I don't think it has to be as sophisticated as the whole shield, because you don't really have to have all the charging circuitry. Like whatever, I could charge the battery separately and not deal with solar.
No, I think if you're doing, if you don't want solar, I think it'll get easier. But I actually bought this kit because it was like an easy, cheap way to experiment with solar, right? So I do want to learn how solar works and how the balance charging of solar plus mains power works. What else was? Yeah, otherwise that breakout board doesn't look too complex. It's got power management. It's got few motor drivers, and it's got the LED strip thingies, the ultrasonic sensors. Yeah, and I think it should be actually one strategy might be to do what Anuraj did with the tumbler, which is have a separate board that just plugs into and sort of like rewires and reroutes everything to an RPi, for example. It would be more complex here than the one with the Nano versus ESP that Anuraj did, but in principle, it should be doable. But yeah,
And the other piece that I don't know anything about yet is that the camera and the camera breakout appear to have some sort of, it's adding some sort of Wi-Fi component.
oh yeah, the camera is on its own little separate ESP32 board, right? Is that how the
Is it a full ESP30? I forgot I was gonna break that out.
It's a peripheral with data and processing needs, so it got its own processor.
Yeah, but the question is the main board's comms piggybacking on the camera's Wi-Fi, or is the camera's Wi-Fi only for the camera? That's what I'm interested in finding out.
I thought it was only for the camera, but you know.
Okay.
ESP32 cam and
Yeah, that's a full
ESP32
board.
cam.
Huh?
We should look up the part number of that and see what it can do. Oh yeah, if you can piggyback other data off of that thing's Wi-Fi, that would be an interesting hack because video is very heavy, right? So if it can transmit video, it should have enough bandwidth to like carry like, I don't know, ultrasonic sensor on a sideband or something. But maybe it's not possible to do.
Can't even get it out of this package. Well, the camera module itself, look, oh. Yeah, okay. So on the back of this little chip is an ESP32 S, which is itself more powerful than the thing that's being adapted to use it.
Oh, okay.
That's hilarious.
We should figure out if we can access it then.
Yeah, somehow.
And does it have a Wi-Fi on it?
Yeah, there's a little Wi-Fi antenna
Yeah.
on the
Oh,
top.
yeah. The antenna, yeah.
But there's no like port to program it or anything like that. Like, it must
Well, if it's connected to Wi-Fi, you should be able to connect it via Wi-Fi, right? Oh, I just shared this tab because I asked ChatGPT a few days ago to compare the power consumption of various boards we are playing with. And this was interesting. It's like a couple of orders of magnitude. I didn't realize it would be so big. A couple of things worth noting. Obviously, the Pis are like, what is it? Between 600 to 700 milliamps. I think this is average load.
Yep.
But the ESP32, while the Wi-Fi is active, is at 150 milliamps. But when the Wi-Fi is asleep, it's basically the same as an Arduino. So it's like intermediate power. So one of the things I think to consider if you wanted to take something like the Sunfounder and like throw out the Uno and put in an RPi instead is you're 10xing the power draw of the board itself. So 700 milliamps, so that's like half an amp. The motors themselves, so it would be like adding another motor. If I remember the TT motors, I looked them up once. They're between 0.3 to 0.5 amps. So yeah, this would be like basically adding an extra motor, and the battery should be able to handle it. I don't know. It was. We never got the BeagleBone is about as powerful as an RPi, I think, in terms of power consumption. And I at least managed to power on the board and 4 motors and 2 steppers with it at the same time. But I don't think I ever had them all running at once. So we don't know if that little blue battery can handle that much power drain. So yeah, power management will be an interesting challenge, I think, if we do this. But I think that's one of the areas we really should try to learn. Yeah.
Are you using power as a proxy for processing power?
No. Here I'm talking like battery amperage.
No, I understand. So I'm asking, are you using electrical power needs as a proxy for processing power?
I don't know if we can do that because I think it's hard to like just eyeball this high level chart and see where the power drain is coming from. Like, why does the RPi take so much more power than an Arduino? I don't know.
So much
Wi-Fi
more.
is clearly one piece.
It's so much more computers than Arduino.
Yeah.
A Pi-5 is a fully fledged computer, basically, while an ESP is a microcontroller. So,
Stop showing this one. Oh,
but this is
So
something
this-
that's very important.
This
perhaps.
ESP32 cam adapter, I don't know if it's going to be clear enough.
is there a part number or something that?
No, they made it. It's just a breakout board that's
Oh.
exposing the serial line to the ESP32, and so I bet it's just ESP32 talking to the Arduino Uno over a serial link, and they've developed a protocol to like communicate with the Uno. So like when you run whatever their control application is, you're communicating with the ESP32. It's communicating with the Uno to like tell it to drive around and react to sensors based on serial commands.
Okay, so
I'm guessing.
it is a pass-through kind of like communications link. It's just not doing much of the sort of like control code.
I think all the control code probably lives on the Uno,
Okay.
and then the comms lives on the ESP32, and it communicates with it that way.
So one interesting compute upgrade strategy would be leave the Uno alone and leave it as the motor control part, but beef up the ESP32, make a new breakout board, reinstall the camera on the new breakout board with powered up ESP32 and do more with the ESP32. So it'll
Or
be
just talk to the Uno with a Raspberry Pi instead.
So, oh yeah, you can do that too, but then you're putting a whole full-size form factor board on top. Whereas if you put an ESP32, you get kind of like a smaller big brain. That's one of the reasons I showed that graph. It's intermediate in power, so it may do what we need. But yeah.
What are the different scenarios in the GitHub repository for the rover? Because if they chose an ESP32 cam, there must be a reason, like maybe doing some object detection, and so then on the ESP32, and maybe sending some signal to the Arduino to stop, to go back, to turn, or whatever. No,
is it doing all that?
I don't think you could really do much in the way of object detection on an ESP32 even. That I looked into it a little bit, and it's like there are builds of OpenCV that are stripped of a bunch of stuff that barely run on ESP32, but it doesn't really seem like it's enough powerful. But I think, so I think I said this last week that I was confused about how this thing had a camera, because for my very first rover project where I tried to use a camera on a Arduino Uno, like the Arduino does not have enough memory to even put a image into memory. It's certainly not enough to like run Wi-Fi itself directly. So I was like, how is this possibly going to work? And so how it works is that the ESP32 has enough memory to actually do stuff with an image, at least to like send it over Wi-Fi somewhere else, even if it can't.
Right now, it's just a remote camera, right? That was the impression I had. You're roving around, and humans are looking at the image for fun. It's not part of the control architecture of the rover itself. Actually, do you know why Wi-Fi is so expensive? Why is Wi-Fi the thing that gets you to mid-grade power from microcontroller?
I would imagine that any radio kind of thing is like, I remember that being one of the most expensive parts about running like a cell phone is that like just powering up the modem to communicate with the cell network is like extremely expensive from a battery life perspective.
Yeah,
which is why early, or maybe this is still true, but like definitely early iPhones, if you were somewhere without a signal, it would just like kill the battery because it would be continuously like waking up the modem to try to like find a tower and searching for one across different bands and like doing all this, and like that is super expensive to do.
That makes sense. All right. Oh yeah, I wanted to spend a few minutes talking about like the ARPA. It's a little bit of a side quest for me, but I thought it's interesting, especially if we ever do things like you had the base station running on your first build, and I think that's an interesting direction to pursue. Either on board have an ARPA doing more, or offline, maybe like with a camera observing what the rover is doing and giving it bird's eye view commands, things like that. There's lots you can do with an ARPA. That's why I think it's interesting. But expanding the ARPA with like a disk and UPS is more interesting challenge than I thought. But let me share the thing I was talking about earlier so you can see what's interesting about it. Well, let's see. Oh yeah. So this is the NVMe expansion board I bought. It is M2. So this little USB dongle thing, you stack the two. Where did we go? Okay. Yeah. Let's see. Hold on. Make the image bigger. Okay. Why isn't this image coming up? Okay. There we go. So that's the board. You mount it with standoffs, and this thing, once you stack the ARPA on top, it goes from one USB port to the other. And this NVMe standard apparently replaced the SATA standard. Okay, the part I wanted to show, the interesting photo, if I can find it. Oh yeah, so this is how the NVMe disk fits in. So this is how you stack them. So there's a little plastic thingy at the bottom. So all this will go on a set of standoffs. So this goes on, then the disk fits on the board side of this NVMe board, which I have. I'm still waiting for the disk, and that fits under the ARPA. And these are the pogo pins I mentioned, spring loaded. So
what's the little USB dongle thing doing?
That's how the
data goes through.
the ARPA talks hard disk through that.
Oh, that's what. Oh, okay.
It's a data bus.
Yeah.
So, meaning it's an NVMe physical plug adapter, but after the interface is through USB basically.
Yeah. So I was reading some forum discussions on that, and it seems that basically means it's not using the full power of NVMe. Like SATA is apparently a slower standard, and putting it through USB doesn't affect it much. But if you have an NVMe hard disk going over USB, apparently that slows it down, that it's probably not worth it. But people seem to be doing it anyway. At least the hardware is available, so that's interesting. Let's see.
The thing that
NVMe is still at least very low power, I think. I think it's probably low power.
It is lower power, I think, yeah. So this is the pogo pin. So this is DigiKey's catalog, and you can see a whole bunch of like form factors. So this is interesting for exactly the reason you said, Mayor. You can like, if you put it on a rover, this is not a super robust connection, but it does free up fairly valuable pins. And I don't know what other strategies there are to like to use the 5-volt and ground pins for more peripherals, other than like put a larger breakout hat with lots more.
But the USB has 5 volts on it.
Yeah, I was going to ask the same thing.
Yeah. So this seemed like an interesting mechanical solution. Go from under and like suck up power from there. What else is there worth looking at? And I thought this was interesting. We talked about the M2 connector standard before, but I didn't actually know what the hell it was. It's apparently this little comb-like thing with like a short comb and a long comb. That's the M2 connector standard. And let's see.
It's one of the main additions on the Raspberry Pi 5 is that you have natively one of these ports under the board.
Ah, okay. Yeah, we should look at an ARPi 5 and ARPi 4 side by side next and compare. But yeah, this is the case I bought. So more interesting mechanical difficulties. The way it's shown set up here, this is just the ARPi, and you can have like a fan, and the fan is another annoying feature. Every fan I've seen uses pins 1 and 2, so it sort of like takes over valuable pin real estate. I'm wondering if there's a better way to run, like important but lower priority peripherals like fans without like using too many ports. Like, why is it this way? Other things this case does. Normally, when you or in the regular setup, if you just buy the ARPi screen and mount the ARPi on it, there's a display driver and then there's standoffs, and you can stack the ARPi on top. But typically, it says drive the screen with like just patch cables to the GPIO or power pins, and that's again using up pins. So this case came with a cable splitter, so it takes the power supply, splits it into two, and sends USB-C to the ARPi, and then has like a USB-A that goes to the alternate port on the screen. So that's another mechanical saving over here.
So
but
it previously would have been, so it powers, like you power the Pi directly?
you power the screen from the Pi. That is the way. If you just buy the ARPi screen kit, that's what it tells you to do. Like the little what is it, a DuPont cable. So you use a pair of DuPont cables from the pins to corresponding pins on the display driver board. But if you do this, then basically you use a cable splitter like this. So this is for the ARPi 5 actually. So let's see. You see this? Yeah. So you just plug the power adapter into this single end and then two power out. So you're splitting it. And in this case, since this is for the ARPi 5, these are both USB-C endpoints. Or wait, no. Or sorry, this is for the USB. This is for ARPi 3. So ARPi 3s and 2s have two USB-As. And for the 4 and 5, you have one USB-C and one USB-A. But yeah, so this is a power management or power delivery mechanical solution, I guess. But yeah, you add a hat to this, you can't put the back panel back on. So since I will be adding the NVMe board, I'll have to take that off, but it's not too bad. I thought it would be way more exposed and fragile, but it looks like this. It doesn't look too bad. So without the cover on, it's, that's the way it is. It's not super robust. I wouldn't put it in the field in the rain or something, but if you want to do that, you should definitely probably design your own waterproof case. But this is actually pretty good, and it stands, folds up. It's like basically iPad type replacement. A couple of fun problems I've been having with it is the way it forces you to install the camera. It's rotated 90 degrees. And so far, I haven't found a good solution in forums for flipping it around automatically, and it doesn't have like an accelerometer or something to like detect orientation and like flip naturally. So right now, if you want to flip the screen, there's a configuration setting that you can rotate the screen in, but that's like clicking on menus and Raspbian and stuff. And for rotating the camera, the best solution I've found is some sort of weird hacky shell script, but that is weird that they've designed this case and the camera the way default installs is 90 degrees rotated, and there's no obvious way to like reorient it correctly. So I guess one of the things I'm discovering is that cheap low-end Unix stuff, you have to like do a lot of stuff that Macs and iPads do very smoothly for you and you take for granted. Anyway, that's my ARPi adventure.
The old joke is that every year is going to be the year of Linux on the desktop. just as soon as they iron out all the bugs.
But this is like still way better than the last time I used Unix regularly, which was still the X Windows era. If you remember that, like 2000 or so, it was crappy. But yeah, this is like almost as good as like Mac or Windows in terms of like very basic functions. Drivers update fairly easily. You have apt and things like that, which weren't there like back in 98, 99. So yeah, I think things have improved a lot for Unix. Oh, the last thing I wanted to mention is since the ARPI boots from a micro SD card, looks like what people do when they add a hard disk is they put all the heavy rewrite duties onto the SSD and try to touch the micro SD as little as possible, because the micro SD apparently for heavy rewrites gets easily corrupted and crashes. And I think you had problems like that with the Spider, right, Eric? Like the micro SD is not a reliable storage solution.
Yes, because the problem is when we lose power. We had a long time where we are losing power all the time because we wanted to do too many things at the same time, and so it happens more frequently on the Raspberry Pi, and that was a selling point for the BeagleBone, by the way. Okay.
Yes.
Where the basically, the power is cut while some system file is written, and then you cannot reboot. You have to. Sometimes you can use your SD card on a PC and fix, okay? But most of the time it's just pretty dead, okay?
Okay, you need a new SD card, basically.
And if you're lucky, you just need to reinstall everything, that's all.
Oh, okay.
Okay.
Yeah, I remember having this conversation when we were evaluating the BeagleBone. I think it had like a very small amount of like onboard SSD memory, and what was it called? eMMC, I think, right? eMMC was the
Yes.
Yeah, but it had the bootloader and basic startup shit right there, so you actually didn't need the micro SD for anything load bearing. So this is something we should probably think about. If we are thinking of the ARPI as the big brain solution for rovers, we should probably actually think hard about, like, can we get away from micro SD dependency for booting and like routine sensor writes and like all sorts of like data operations? Like, can we actually like hack the BeagleBone type of solution? Like not just this kind of SSD that I'm doing for a tablet type form factor, but like something small for booting, and then it can phone the rest of the data home. Like, yeah, what's a good strategy here?
I think if you connect a USB hard drive, it should work.
So like a thumb drive, you think that's good enough?
Why wouldn't it?
Can you?
Yeah, I mean, you have to change some settings with software.
Yeah.
Well, there's also a question of lifetime, and like what the expected lifetime is.
Well, the thumb drive and the USB and the SD card should be about the same.
And the advantage of the thumb drive is it's physically more robust and can handle more, and it's an SSD, so it won't have corruption problems, right? Whereas the micro SD is magnetic, if I remember correctly.
No. They're both the same technology. They're both flash memory.
They
but
are?
if you use an external drive. When I say external drive, I mean flash. I wouldn't want to put a 3.5 inch or 2.25 inch or whatever on a robot to bounce up and down. It's also not as fast.
Yeah, and it would be a bigger power drain. I think the size of hard disk I'm buying is like 500 GB, so that's probably too much for a rover to have on board, right?
No, wait. You don't need more power because you have more memory. It's just larger. The power is used up when you erase. Also when you write. But my point is that if you use a hard disk, flash drive hard disk, you have a lot of technology options to choose between, including ones, with more reliability and whatever it is you want.
So we should experiment with this. Like, can you, since the ARPI has 4 USB ports, you could actually plug in 4 thumb drives and create kind of like a hacked RAID array or something, and create like
you can literally create a RAID array.
That's what I did in my Spider. In my Spider, I attached a small hard drive using a flash memory hard drive, and I don't remember anymore if I booted from it, but I definitely wanted to.
Well, that could be the big advantage, though, is just by having 2 storage solutions. The first one that maintains the system can be read-only. Yep. And so you don't have to worry about interrupted writes or degrading the storage from multiple writing, and then everything else can be shifted to the other drive, and then at least you have a working system, even if it can't store new data to disk.
Okay.
Yeah.
Yes,
Which is roughly how the like Apollo core rote memory stuff worked. It's read only. It had to be hand woven on Earth, and then there was no chance of radiation or anything flipping bits or causing problems.
And that's often the solution adopted for Raspberry Pis, that are sent out there. That on the SD card it's read only, okay? Because the problem is to wear out the SD card by writing to it, basically.
Yeah.
Read only is then it has a much longer life, okay? And all the data, which is usually on IoT devices, the data is transient anywhere. It will be stored locally up to the time it will be sent to some API or whatever. Okay. So it's a small flash drive or something like that, basically. But
just on logs and stuff.
The Pi 5, there is now the M2 connector, so it just allows to have this as an option as well. So if you don't want to use too many USB ports, for example.
Looking at the Wikipedia page for micro SD to see exactly how it works.
Yes. Is this so the magnetic part?
Actually, can't figure way too much detail. No, I think it is solid state. Yeah.
But the advantage is really what Red summarized, okay, is to separate the operating system, which is really critical, from the data, which is the application side, basically. Okay. If we lose the application side, it's inconvenient, sometimes critical too for the business, but at least as long as we don't lose the operating system, we can do something. Okay. So typically remote debug. Okay. If we lose the system, then we break the whole thing, basically.
So the reason I was asking about magnetic versus solid state is it's not clear to me how solid state degrades. Like it is a kind of DRAM, right? So it has very low power refresh thing going on inside.
No.
Okay, how does it work?
No, solid state. It has these little cells which store charge.
Yeah.
And permanently. And in order to write it, okay, you have to change it. But after you write, you can change. When you write, you can change it from 0 to 1. But if you want to rewrite and change it from 1 to 0, you have to erase an entire block with a high voltage.
Yeah, I get that.
Those are the words. Those are the words. High voltage. You're really getting into it. So after a while, some of the memory units stop flipping back.
Okay. Yeah, so why isn't that also a problem with USB thumb drives?
It is.
It's also a problem, but if you lose the USB thumb, you don't lose your operating system.
It's a problem.
You could have dual SD cards. That'd be fine, right?
Okay, so basically any redundancy would work. We don't care about micro SD versus USB or this NVMe. Any redundancy with separation of critical operating system being read-only and working memory being read-write, that's a good solution. Is that right?
I would just qualify what you just said. If you have 2 drives acting as a RAID array, so you have real-time redundancy. Well, if you have 2 drives the way we just described, if something goes bad, you simply reboot. So I think we're happy to do that.
So it's application specific, basically. It seems to me that for us, most of the time, not worrying yet is not a problem, basically.
But this seems like an interesting experiment because brownouts, I think, are going to be one of the most common scenarios, especially if you're running on like batteries on the edge of capacity.
Yeah.
Sunlight has gone off and solar power is weak. So maybe we should actually run experiments on like the edge of brownout. Like, can we?
Sure.
How well can we run a rover where it keeps browning out unpredictably every 15, 20 minutes? That would be an interesting experiment to run. Like, can it always reboot safely using this configuration you guys are describing? That I'm curious to see that because, yeah.
Why 15, 20 minutes for the way we're using rovers, I think is meaningless.
Okay,
You know,
whatever
the
the
rover-
right duration is.
No. Let me
It's not so
explain.
much sorry, but it's not so much the duration. It's how much data you write to disk. And so, for example, for us, Meyer, we most of the time we were not using the disk at all. Basically, we are just controlling the rover and doing some scenarios. Okay. Remember
Right.
also all together when we had the competition, to find the gates. Okay. Same, we're not writing to disk basically. However, for example, when Red starting to do computer vision stuff, okay, or only just transferring images, then he may be more write intensive. Okay, and so that may be a good reason then to make the split. And just to finish, for Meyer and I, when we worked, the reason why we worked on that just because it's cool, okay, but also because we had a power problem. Okay, so we had many cuts. Okay, so that was more the driver than the data write quantity basically.
Yeah, I think there's a couple of other considerations worth keeping in mind. You guys remember, like, back again in the 90s, people would actually use a command called park to park the drive head of magnetic disks before moving them. Like, because the drives were so big, you had to park the head to move the computer physically. And I think the equivalent in rover stuff is if you're like sitting in one place and measuring the temperature or like taking photos and saving them, you're probably safe. If you're beginning to move the rover over rocks, chances are you're going to like maybe jiggle power.
Flush the cache.
Yeah, exactly. So save it, maybe back it up or do whatever redundancy stuff you're doing and then move. So it's kind of an interesting coupling between physical operations and data operations. So that would be kind of an interesting low level and mechanical resiliency management problem, I think.
Oh, it's also kind of a mission planning problem of like,
Yep.
Once you stop to do something, make sure you finish up with what got all the data you want, because you never know once you start moving what's going to happen next.
That leads us back to operating systems. What you're saying is to define atomic actions. But I want to point out, if you are a human is actually not a good example because we can fall. But if you're a snake and you suddenly blank out for a minute, nothing happened. Maybe that rabbit you were about to eat got away, but nothing happened. You didn't fall. You just get a new picture and you process it again. So it's really very important how you use a rover. That's why I was saying that the way we use them, getting a brownout every 20 minutes doesn't mean much. It's like a senior lapse, you know? So for minutes, the rover shuts down, boots up. It wasn't barreling down the highway at 60 miles an hour.
But it might have been precariously poised on the top of a rock about to climb down, and it loses motor control and falls badly.
No, it freezes. It freezes.
Yeah, but if it freezes in an unstable position on a steep slope of a rock that it's crawling down and loses traction, it can slip and fall. I mean, for the elderly, falling is the big.
That is true. Before you do some things, you have to make sure that you have everything you need to finish them.
Yeah. So rovers are not fast moving and are not doing like dynamic fighter pilot type stunts, but they are moving on rough terrain with like weird conditions, steep slopes, rubble, slipping footage. Lots of things can go wrong on from a terrain point of view.
Yeah.
And okay, yeah.
Do snakes eat rabbits?
Pythons, the big ones.
Oh yeah. Okay.
Pythons eat entire deer. They can eat really big animals. Yeah.
I don't know. Medium has a question. Do snakes eat rabbits? The answer is yes.
Okay.
Plenty of snake species can eat full-size rabbits as a whole.
Okay.
I don't know.
That's you don't know.
The moment of nature is murder, Zen, and it is 10:30. So
Yes.
yeah,
Cool.
hopefully next time we'll have like 2 of these rovers running and can do a demo session on the Galaxy. And yeah, we have to get back on the Farcaster track when Arunraj comes back.
Right. On Tailscale.
All right.
Yes.
Okay,
So
guys.
thank you. Good night and good day.
All right.
Yeah.
Cheers.
Bye.
Bye-bye, Maya. Thank you.